This is Udayita from TechSpark bringing you another session covering data engineering question and answers. And in today's session, we're going to explain the different file formats that is present in Hadoop, not only in Hadoop Data Lake, but we can use them in the different cloud storage as well. So as usual, I'm going to start off with a brief introduction of myself. I have been working in data engineering domain for almost 9 years with various projects and involved in creating data pipelines, both in on-premise and in cloud storage for several clients. I also train candidates in this field to help them build an individuality profile with our comprehensive course covering all the necessary topics of data engineering. So do reach out to us in case of any queries or any concern. Okay, so now before starting off with the file formats, let us look at on the high level how the row and the columnar storage looks like. I mean, what are the differences and how do they actually work? So if I talk about row-based storage, it stores entire rows of data together. It is commonly used in traditional relational databases. Each row is stored sequentially on a disk. So each and every line or each and every row will be stored sequentially one by one in the disk, and it is best used for the best use case for these kind of storage is obviously the OLTP or the online transaction processing. Since all column values for a row are stored together, reading or updating a single row is very fast. So whenever we try to do any sort of insert or update any record, in that case inserting the whole record, like appending to the bottom, or in fact updating something in one record, it's much easier because every single processing will be done for each and every row, and when it comes to writing, then sequentially it will keep on adding each and every line uh, one after another. Okay, the second one is it's good for insert and update operation. Just with what I said, transactions that involve frequent row modifications benefit from this file format. But there are some disadvantages as well. Let's look at them. One is it's not really efficient for analytical queries. If you only need specific columns, reading entire rows results in unnecessary IO. Obviously, if I have say 100 columns and I am required to use only 10 out of them, then it will regardless, it will try to scan all the 100 columns. Since it will do the processing, it will try to scan each and every row or each and every line of the table. Okay, so that is something, so that takes a huge toll whenever we are just trying to process or kind of fetch some specific amount of data or specific amount of columns, so to speak. It doesn't also have a good compression, so whenever the data is stored, it won't be compressed, or it would take much more space or much more volume compared to the other one, that is the columnar based storage. So that's also one of the disadvantages. Use cases is usually the OLTP systems like MySQL, PostgreSQL, SQL Server, or any kind of RDBMS, so to speak, where we need to insert and update records on a daily basis. And the most important thing is we won't be reading, say, a couple of columns or some chunk of data, where mostly the processing will be done on writing it as and when the data comes. Now let's take a look at the column-based storage. So from the name, you can understand that the previous one was writing for each and every row. In this one, it would be done for each and every column, right? Columnar-based storage stores the data by columns instead of rows. Instead of storing entire rows together, columnar storage keeps value from the same column together. So it has some advantages, because since we're grouping the columns and not the rows, not the each and every line or record in the table. So it does have some advantages. In which cases the advantages comes in, let us take a look. One, it is efficient for OLAP, which is the online analytical processing. So queries that aggregate or filter specific columns can only scan the necessary data. Okay, so that's the huge advantage when it comes to we are trying to fetch or read or even scan the big data. The data from the Hadoop cluster or from AWS S3 using Hive or PySpark or anything. Over there, it is much more robust, or it is much more convenient for the users, because since in the big data the volume would be huge, and if we try to read or process some amount of data, and obviously we don't want to use the whole row of it or the whole record of it. What I'm trying to say is that the same example that I have say 100 columns and I want to process or I want to read only 10 columns out of it, be it Hive or Apache Spark, anything. In that case, reading only those required 10 columns and scanning only that chunk of data is much more efficient for our jobs to run. So that's one huge advantage. The second is the high compression. Similar data types are stored together, allowing better compression. So usually these storage, these column-based file formats, they are highly compressed. Even though there are some different modes of compression like Snappy, JSON, each and every compression modes has its own features or qualities, but by default there would be some form of compression will be will be incorporated in whenever you try to store say a Parquet file on ORC file. If you see compared to the same volume or the same record is being stored as in CSV file, you'll see the differences between the volume of the store it takes up. Okay, be it any Hadoop data lake or any AWS cloud storage. Any cloud storage, be it AWS or Azure or GCP. So when it comes to storage, obviously the costing amount will also come into play, right? So when we move to the cloud storage, there would be some different costing based on what values or the what volumes have been occupied. So if a file say 1 TB of CSV file with some records, say 100 records, it's taking 1 TB storage in the AWS S3. When I try to store the same records in a Parquet file on a ORC file, I see it's around like 100 or 150 GB. Okay, so it's almost like a 10x data reduction. I mean the 10x volume reduction, right? So accordingly my cost will be 10x reduced. So that's the beauty of it. If we try to store columnar, if you try to store the big data where the large volume of data will be stored for processing, if we use the columnar based storage, in that case that helps us not only in efficient or faster query performance, but also the cost optimization takes place. However, there are some disadvantages, right? Whatever the store-based storage or the file formats can do perfectly in a better way, columnar-based storage is unable to do those things, like the optimized the alterations. For example, if I try to insert, update, or delete an entire row, it is not efficient because multiple column files need to be modified. So that's one thing that we have to keep in mind, that if I am going to insert, update any record more frequently, in that case columnar is not the choice for us. But in big data, since you know that most of the tools, right, be it Hadoop, Hive, Spark, they all immutable, means you cannot update any data over there. You can simply process this, you can create another data frame, you can create another table out of the data or after doing some modifications, but you cannot change it. So in those cases we don't really need the row based storage. Columnar kind of is sufficient for us. So use cases as usual, the big tables or the large warehouses such as Amazon Redshift, Google BigQuery, Snowflake, Apache Parquet, Apache ORC, which are used in Hive. So these tools or these places where the columnar-based file formats can be used efficiently. So now let's take a look at the most popular file formats, that is the Parquet, Avro, and ORC. What are the differences between them, and when should we use them is the most important question. Okay, so the Parquet is best suited for read-intensive analytical workloads due to its efficient columnar storage and compression. Okay, so Parquet and ORC out of the three are the two columnar-based storage, and the Avro is the one that is row-based file format. So if I try to read data more often than not, be it with partition or for some other processing, in that case, Parquet or ORC is the best fit. But still, there are some more specific use cases that even if I try to choose between Parquet and ORC, which one should I choose and when? So Parquet is best fit for Spark. For Apache Spark, Parquet processing is much faster compared to ORC. On the other hand, ORC is optimized for Hive and offers better compression and indexing features than Parquet is much more Hive centric. Okay, so I'll come to this indexing later. So first of all, there is something known as vectorization. For each and every file format, this vectorization is provided, and for which tool it is best is basically if I use Parquet, then for Spark the vectorization is good, and if I use the ORC, then the vectorization for Hive is better over there. What is vectorization? Is basically when I try to read or try to scan some data, in that case, the data won't be read like one record each. Okay, instead it will try to scan a block of data. So what will happen if I say 10,000 rows or 10,000 records, and if I try to read them, or if I try to scan the data using blocks, in that case, suppose using only 100 blocks, the 10,000 rows are read, right? So that is the beauty of the vectorization. That's how it helps in scanning the data in much faster and optimized way. All right. And now coming to ORC. ORC, so similarly, this vectorization works well with the Hive when it comes to ORC. There is some more, how should I put it? I mean, better features that ORC provides than Parquet is that compression. Okay, so if you look at this chart over here, the ORC is something which is giving the most compression. I mean, it is giving the quality of compression better than the Parquet and Avro. Okay, Parquet has even better than Avro, where the Avro, the compression is very bad, so to speak. Okay, so if I talk about Parquet and ORC, the compression is something that ORC has much more than Parquet, and also ORC helps in indexing in Hive. What is indexing? Is suppose there is one column which is not partition, right? Apart from the partition column, I want to use another column for filtering where I'll be putting where clause. In that case, if I create an index on that where clause, so the query when I'll be incorporating the where clause onto that column, it's gonna give me, or it's gonna fetch the results much faster than without the index. Okay, so that's how the indexing helps. So there are different kind of indexing. One is the bitmap indexing, the other one is the compact indexing. So usually compact indexing is by default what happens, but that's as much about it. I mean, in real world projects, I've rarely seen like any project using indexing. Partition is something that is highly used, extensively used, and the concept needs to be cleared about it. I mean, the basic difference between partition and indexing is that indexing happens on metadata level, while partition happens in the Hadoop data lake, I mean the storage level. What I mean is, if you have gone through the Hive partition session in one of the earlier um, topics, so you might have noticed that when we create a Hive table on top of a partition data, in that case the folder structure looks entirely different. It's something like the partition key equals to the partition value, the column value. That's how the folders are created, and that's how Hive recognizes or acknowledges the partition that the table has. And obviously I have to define the same while creating the table. But when it comes to indexing, I don't have to put the index statement in the create table command. What I have to do, I have to create a separate index pointing to that column of the table, and then when I try to query the table using the where clause for that column, in that case I'll see the differences. Okay, and that column would be something other than the partition column, because already partition column is optimized, right? No need to do indexing on that. So that is the significance of indexing, and ORC is the best way when it comes to Hive indexing, because it does this vectorization, right? It will read only a chunk of data, and that too with for a particular column, right? So that will be like a double win for any user who's trying to access the Hive table. Okay, so this is all about Parquet and ORC. And yeah, obviously, if I talk about schema evolution, none of them have so much, but Avro has it. So I'm be coming to Avro later. So, and you see the compatible platforms like ORC is best fit for Hive Presto, whereas Parquet is good for Spark or Arrow Impala, and both of them are column, and both of them are good for OLAP or read processing data, right? So now coming to the last one, which is Avro. So Avro is best suited for streaming and real-time applications, okay, such as Kafka. Okay, due to its row-based formats and excellent schema evolution, Avro is used for storing the data, or using being used where the data will be written more often than not. So if I have a streaming pipeline, right, in that case, for each and every second the data is being stored, each and every record will be written. So in that case, obviously my choice will be Avro when I'm trying to read the data more often than not. And one more thing, the Avro that comes for, which is kind of like bonus thing for the real-time processing, is the schema evolution. So what is schema evolution over here? So Avro gives the best support for schema evolution, whereas the Parquet and ORC gives little to nothing. Okay, so schema evolution means today suppose I have 10 columns, and tomorrow it could be either 11 or something like 8, 9. What I'm trying to say is that tomorrow it may so happen that one or two columns have been added, or maybe it has been deleted from the table. or from the incoming source. Okay, so in that case, I will have to again change the table definition, everything, if I'm using Parquet or ORC. But when it comes to Avro, it's not like that. Okay, all I have to do is just change the schema file. So what is schema file? So Avro stores the schema in a different AVSC file that is totally detached, or that is totally separate from the actual data file. The actual data file will have the extension as .avro. I mean, like the others, the actual will have .parquet and .orc. Avro will have .avro. But you'll see whenever you try to write data in Avro file format using, say, Apache Spark, you'll see in the target path location there would be two files generated. One is the .avro file where the actual data will be stored, and the other one is the .avc file where the schema will be stored. And this is pretty much how the schema file looks like. If you see over there, book.avc is one avc file that is being used for storing the schema of the book.avro file. Okay, and it looks like much like a JSON format data, even though it's completely not JSON format. It has some other attributes right at the top of the data, that is right at the top of the schema, that is the namespace, the type, name, and everything. But apart from that, if you look at the fields, these are the fields or the column names that are being used. One is the name, the other one is the ID, and the category. Okay, for each and every column name there would be data type also, like string. ID is an integer and it can hold null values. For category as well, it can have a string and can hold null values. So this is how the avc file looks like. And this is the reason schema evaluation is something that is possible for Avro files, because all I need to do is here, suppose tomorrow another field, say department or salary, has been added. So I can just edit this AVC file. I can add that column over here with this dictionary format, and then that's done. Okay, my Avro data will automatically recognize the new column added in the schema, and it will try to fetch accordingly. Similarly, if one or two column is deleted, in that case I will simply just remove them from my AVSC schema file, and that will do. Okay, so these are the differences, basic differences between Parquet, Avro, and ORC. Every file has its own feature which works well with different other tools. It's not like that you can ask me which is the best file format. I will simply ask you what is the requirement that you have. Okay, what tool are you going to use? If you're going to use Hive, in that case, use the ORC. If you're going to process the data using Parquet, in that case, just sorry, if you're going to process the data using Apache Spark, then go for the Parquet. And if you have a real-time streaming data pipeline to be to built on, in that case, you can go for the Avro file. Okay. So this is all about the different file formats and how do they work, and where are these use cases are. So just reach out to us for more. I mean, if you want to get an overview of the course that we deliver, just reach out to us. We also provide job assistance, that at the end of the course we make sure that your profile is ready for the interviews to be cracked, and you will be noticed by different companies when we create your CV. So in our course we cover all the necessary tools elaborately, such as the Spark, Hadoop, Hive, AWS, with hands-on coding and real-world project. Do reach out to us for in case of any help. This is Uday signing off from this session. Bye bye.
Contact us for the free job assistance. We will help you to get the IT job. Please like, subscribe, and share the channel for more regular updates from TechSpoke.